projects. In this video, we are going to explain about a project titled Heart Disease Prediction using Machine Learning Techniques. Heart disease is a widespread and critical global health concern impacting the millions of people. Our project endeavors to create a precise and user-friendly system for early detection and the risk assessment. We leverage advanced machine learning algorithms like of decision tree, random forest, SVM and neural network and of many more to analyze the diverse patient data such as age, blood pressure and cholesterol levels and of many more. Through data pre-processing and the feature engineering ensures the quality and relevance of the training data. By evaluating and refining the model, we aim to achieve optimal predictive accuracy. Our ultimate objective is to equip healthcare professionals with a potent tool for identifying the potential heart disease risks and facilitating the early intervention and enhancing the patient outcome. This contributes to a healthier society and elevate the burden of heart disease. And the primary goal of this project is to develop an encompassing and highly precise heart disease prediction system by employing a diverse set of machine learning algorithms such as SVM, KNN, neural network, random forest, decision tree, Gaussian naive Bayes, logistic regression, XGBoost, AdaBoost, and voting classifier. By capitalizing on the unique strength of these algorithms, we aim to construct an ensemble model that maximizes the predictive performance of the robustness. The system will analyze the crucial patient data, including the age, blood pressure, cholesterol level, and the other attributes too, which identify the potential heart disease risk. Through extensive data pre-processing, model training, and hyperparameter optimization, our aspiration is to achieve the remarkable accuracy and equip healthcare professionals with a dependable tool for early detection, proactive management, and personalized treatment recommendation. The ultimate objective is to make the substantial contribution to enhance the patient outcome, elevate the burden of heart disease, and elevate the public health standards. These are the basic requirements that are needed to build this project. The software requirements are Python IDE with version of 3.7, Anaconda with version of 3.7, or Jupyter. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the libraries. In this initial step, necessary Python libraries such as NumPy, Pandas, sklearn, TensorFlow, Keras, and Matplotlib are imported. These libraries provide essential tools and the functionalities required for handling and model building, evaluation, and the visualization. And the second one is importing the dataset. The dataset containing the patient information, including age, name, gender, blood pressure, and the cholesterol levels, is imported from a CSV file. This dataset serves as the foundation for training and evaluating the heart disease prediction model. And the third one is splitting the dataset. The dataset is divided into the two subsets, the training set and the testing set. The training set is used to train the machine learning model, while the testing set is kept separate for evaluating the performance on the unseen data. This ensures an unbiased assessment of model accuracy. And the fourth one is building the model. Here we applied various models. That first one is SVM, stands for Support Vector Mission, is used to classify the patients into heart disease categories based on their attributes. It finds the optimal hyperplane that maximizes the margin between different classes, making it a powerful classifier. And the second one is KNN, stands for K nearest neighbor, classifies the patient based on the similarity of the attribute with the K nearest neighbor in the training set. It is a simple and effective classification algorithm. And the third one is neural network. A neural network with multiple layers is employed for its ability to learn the complex pattern and the relationship in the data. It offers the flexibility and adapts to the non-linear relationship. And the fourth one is random forest. Random forest is an ensemble learning method that combines the multiple decision tree to make the prediction. It reduces overfitting and provides the robust prediction. And the fifth one is decision tree. A decision tree is a tree-like structure that splits the data based on the attribute value to make the decision. It is interpretable and easy to understand. And the next one is Gaussian naive Bayes. The Gaussian naive Bayes is generated by the probabilistic algorithm that uses the Bayes theorem to classify the patient into the heart disease categories. It assumes that the features are conditionally independent, making it computationally efficient. And the next one is logistic regression. The logistic regression predicts the binary outcome, making it well suited for the heart disease prediction. It models the probability of the patient having the heart disease based on the attribute, facilitating the risk assessment. And the next one is XGBoost. XGBoost is a gradient boosting algorithm with superior performance on the diverse dataset. It aggregates the multiple weak learners, creating a powerful model for heart disease prediction. And the next one is AdaBoost. AdaBoost is an ensemble method that combines the weak learners, assigning the higher weights to misclassified sample to improve the model accuracy. It excels in creating a robust and accurate heart disease prediction model. And the final one is voting classifier. The voting classifier combines the prediction from the multiple models considering the majority vote to produce the final prediction. By aggregating the diverse classifier, it enhances the overall prediction accuracy for the heart disease classification. And the voting classifier, we have two types of voting, that is soft voting and the hard voting. It's based on the average of the voting or finding the majority of the voting. And the fifth step is comparison graph. A comparison graph is created to visualize the performance of all the models. The graph displays the accuracy, precision, recall of each model, enabling the easy identification of the most effective algorithm. And the sixth one is the training model. The training process involves feeding the pre-processed training data into each machine learning model. The models are trained on the data set to learn the pattern and the relationship between the attribute and the heart disease outcome. And the seventh step is user gives the input. The project includes a web application built with the Flask framework, allowing the user to give the input like of details such as age, gender, blood pressure, and cholesterol levels. And the eighth step is the given input is pre-processed for prediction. When the user gives the input the information through the web application, the data is pre-processed to align with the requirement for the trained machine learning model. And the ninth step is trained model is used for prediction. The pre-processed input data is fed into each trained machine learning model, where each model predicts the likelihood of the user having the heart disease based on the input attributes. And the last one is final outcome is displayed. The predictions from all the models are collected and the final outcome is displayed to the user through the web application. The user can view the predicted result indicating whether they are at risk of the heart disease with the certain percentage too, facilitating the early detection and the proactive management. The execution of the project. To execute the project, first we need to open the code folder. This is the code folder containing of the various files within it. The dataset folder containing of the dataset that we used and this project, and the static folder containing of the CSS, images, JavaScript, web fonts within it. And the template folder containing of the various HTML documents like of about, home, index, result, sign in and sign up pages within it. And the app is an py file which contains the algorithms front-end logic, it could include the code written in Python that handle the server-side operations such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And these are the PNG files, and the heart emblem is an IPYNB file which contains the combination of the code, graph, and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And the model.svi file contains the algorithm information, and this will be used at the time of execution of the project to perform some specific task like of predicting the new data. And the signup.db is a file appeared to be the database file used to store the user information. And to execute the project, we built a Flask framework as a front end, and the overall code that is present in the Jupyter notebook containing of the code, graph, and output all in one place. For the execution, first we need to copy this code folder address and then open the Anaconda prompt. Here first we need to change this disk location as F because our code folder is present in fdisk, and then write a command cd space and paste this code folder's path. By this it changes the directory to the code folder's path, and then write a command python space app.py. By this command, it will execute the Python script and perform a runtime check for any syntax errors or logical issues. And then click on enter button. By this app.py file will run. The Flask framework will host the application locally at the default address with the port. And we need to copy this local link on any of the web browser, and I prefer to use of Google Chrome. And I'm opening this Google Chrome and pasting this local link, and then click on enter button. Here we redirected to this home page and contains of the home and sign up buttons, and clicking on the sign up button, it redirected to the sign up page containing the necessary details that need to be filled for generating a new account. But my account is already generated, that's why I'm using the sign in button, and here redirected to the username and password, and we need to fill these details as of username of admin and the password as of admin, and then click on sign in button. Here it redirected to the index page. We need to fill these details to predict whether the person is having the heart disease with the approximate percentage. And username as Sri, and age as 21, and the female or male as gender with female as 0, and the constrictive priorities as of 0, and the resting blood pressure is of 80, and the serum cholesterol is of 133, and the fasting blood pressure is of 0, and the resting electrocardiographic result is of 0, and the person's maximum heart rate achieved is of 105, and the exercise induced angina is of 0, and the old peak is of 0, and the slope of the peak exercise ST segment is of 1, and the calcium is of 1, and the thalassemia is of 3. And then click on submit button to predict the heart disease of that person. By clicking the submit button, here we have a chance of having the heart disease probability is of 31%. And click on the back button and refresh button, and here we can enter the details as of name, Lakshmi, and age 57, and gender 0 as of female, and 0, and resting blood pressure is of 120, and the serum cholesterol is of 354, and the fasting blood pressure is of 0, and the resting electrocardiographic result is of 1, and the person's maximum heart rate achieved is of 163. and the exercise induced is of 1 and the old peak is of 0.6 and the slope of the peak exercise ST segment is of 2 and the calcium is of 0 and the thalassemia of 2, and then click on submit button to predict the heart disease. After submitting, the result page is as you have a chance of having the heart disease. Probability of having the disease is of 77%. And then click on back button. And this is the comparison graph where x-axis represents of the algorithms we used in this project and the y-axis represents the score of each algorithm accuracy, precision and recall. In conclusion, our project developed an ensemble model using the machine learning algorithms such as SVM, KNN, neural network, random forest, decision tree, Gaussian layer-based, logistic regression, XGBoost, AdaBoost, and voting classifier. The comprehensive system accurately assesses the heart disease risk based on the patient data, contributing to early detection and the proactive intervention. By optimizing the model performance through data pre-processing and hyperparameter tuning, we have achieved exceptional predictive accuracy. Our project's significance lies in its potential to empower the healthcare professionals with a reliable and efficient tool for the timely risk assessment and personalized treatment recommendations. This endeavor reinforced the importance of integrating the artificial intelligence in healthcare, promising the improved patient outcomes and a positive impact on the public health. We envision our work opening the new avenues for the advanced medical diagnostics and predictive healthcare applications.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.